Alright guys, so today we're going to continue on solving equations. The equation on the screen looks relatively more simple than the one that we've been working on in class. Just remember that I'm showing you some more of the basic stuff. Today we're going to solve equations using the undo table. This is a brand new way of solving equations. I like this method because you're describing what's happening to the variable and then you're going to undo it or unbalance it, and then it also allows you to be able to check your work at the same time. So in your composition book, make sure that you can write I can solve equations by using the undo table. I want you to copy this example down. The first thing I want you to do is I want you to go to the equation that they give you, and I want you to just put a rectangle around each term with the symbol to the left of it. That should be the first thing. We're just organizing information. So here I have a -3, I have a positive 4x, and I have a 13. I know that 13 is positive because there's no negative sign in front of it. So if I were to describe this to you, I would say that here's my number. It gets multiplied by 4, and then it gets added to -3. The result is 13. When you are filling out the do column from right here, starting right here, when you go top to bottom, you're always going to follow your order of operations. I'm going to write order of op for short. You'll always follow your orders of operation. So what I'm going to do is put a rectangle around my -3, put around my positive 4x. Remember, you always put a rectangle with the symbol to the left of it. Do column. Here's my first variable, my only variable. It's kind of like my present. We talked about wrapping presents in class. Here's my present. You always look in the rectangle. What's the first thing that happens to your variable? Well, I can quickly tell that right here it's being multiplied by 4. And then it gets increased by -3. Okay, and then immediately I'm going to check. I have everything that's happened to the left side already written down. The other side is just 13. I'm going to leave it alone. Immediately I'm going to go in and do the opposite, or undo all of that. So the opposite of adding -3 is subtracting -3 right there. We don't subtract in math anymore. We add the opposite, so a minus becomes +3. The inverse of multiplying by 4 is dividing by 4. So what I'm doing is I just described what happened to my variable. I undid it. The first thing at the very bottom of the undo right here, I'm going to check it so you can see it. I'm going to go in and just write that underneath my equation, +3. Draw my line. -3 with +3 is 0. Bring down the 4x is equal to 13 plus 3 is 16. The next thing I have to do is divide by 4. So I'm going to go in here and divide by 4. And my answer, 4 divided by 4, is just 1x. 16 divided by 4 is equal to 4. Okay, so if you look again, the undo, at the very first thing that I did right here is add 3. I put it over here, divided by 4. That was my next thing. I like this way because if I put in 4 for x, 4 times 4 is 16. 16 plus -3 is 13. So you're also checking your work at the same time. Okay, let's go to the next example. 3m plus 9 is equal to 21. Another way someone can describe this is a number multiplied by 3 increased by 9 is 21. So the first thing I'm going to do is put a rectangle around each term with the symbol to the left of it. So I have a +3, a +9, and a +21. And then I'm going to build my table over here. My do, undo. So here's my do, here's my undo. Here's my present. The first thing that happens to it is it gets multiplied by 3. Sorry, my board's running out of battery. And then it gets increased by 9. I can see that. Again, following your orders of operations on the do. You multiply before you add. Undo, I'm just going to go ahead and write the inverse of each of those. The opposite of +9 is -9. The opposite of multiplying by 3 is dividing by 3. This right here tells me what I need to do first. So I'm just going to -9. If you want to, you can also write 21 right here as your result and draw your arrow, and lets you know that's the first thing you need to do. And you get, bring everything down, 3m, that cancels out, is equal to 21 minus 9, right, is equal to 12. And then I know that the next thing I need to do is divide by 3. So divide by 3. I'm just following the undo column, starting from the bottom up. This cancels out. I get m is equal to 4. Then we'll put that in my table, 4. 4 times 3 is 12. 12 plus 9 is 21. See, it's all, you're doing it, you're describing it, and then you're doing the inverse, and you're checking your work at the same time. Okay, last example. Build my do table, column, undo, do, undo. Here's my n, put a rectangle around it. That's a positive, that's a negative 14, and that's a positive 1. Check it out. Here's n. First thing that happens to it is gets divided by 3. Next gets minus 14. Immediately go into the undo. The opposite of negative 14 or minus 14 is plus 14. And then the opposite of dividing by 3 is multiplying by 3. I'm going to go ahead and put 1 over here. Draw my arrow. So the first thing I need to do is add 14. I'm just going to put that right there. So I get n divided by 3 is equal to 15. Because negative 14 with positive 14 is 0. Next, I needed to multiply by 3 to both sides. I hope you guys continue to see the pattern that whatever we do to one side, we do to the other side. This goes away, becomes 1n, or just n, is equal to 45. I can quickly check my work. 15 divided by 3, 45. 45 divided by 3 is 15. 15 minus 14 is 1. So I know that 1n, or just n, is equal to 45. So in review, the first thing you always want to do is put a rectangle with the symbol to the left. And then build a do, undo. And that's how you solve multi-step equations. We'll practice more in class. Thanks, guys.